Principle of superposition. The name superposition implies that we need more than one. Here in this particular context, we are talking what will happen if two or more waves move through a medium simultaneously. We have done for one wave, we have crust troughs or compressions, rarefactions, but imagine if this is a point in the medium, maybe water, if we are considering the water waves, or maybe two sound waves, one particular medium in the one particular point in the medium where two sound waves are coming. Same way, two light wave maybe. And suppose due to first wave, two waves are coming at this point, one wave produces a crest at this point. Crest means it will take this particle up. Just keep in mind again water waves to be the simplest one. Water molecules, and then one disturbance comes which take the water molecule up. If there is another wave which is also coming and then it also produces a crest, then what will be the net displacement? It will be added. And same way, if one wave is producing a crest and another one is producing a trough, the resultant may be zero. I am saying maybe because it depends on the relative values of amplitude. It is actually the difference of the two. So if the amplitudes of the two waves are same, then it will be zero, otherwise it will be the difference. Same way, if there are two troughs, then it will be down. This is what we mean by principle of superposition. So we can state the principle of superposition as when two or more waves move through a medium simultaneously, then the resultant displacement is equal to the vector sum of displacements due to individual waves. Listen again. When two or more waves move through a medium simultaneously, the resultant displacement equals the vector sum of displacements due to individual waves. So this is what we mean by principle of superposition. And then now we will see how principle of superposition, when we have two or more waves in a medium, this leads to interference. Interferences, let me take let us take S1, S2 are two sources giving us light waves. Okay, so one light wave coming from here, another one from here, and let us take this distance as large and these as very close so that the two waves are traveling almost in same direction. Okay, now P is a point and two waves are reaching here. I want to apply the principle of superposition and see what is happening at this point. Suppose this is the situation. 1, 2, 3, 4, 5, 6, 7, 8. We are getting 8th crest at this position P. And same way we have this is the 14th crest. We have taken frequency of the two waves as same. Two conditions I am taking. Frequency same and this situation is not changing. Means at P we have crest due to one and crest due to other. This is the situation. What will happen? We will have an intensity which is which is large, high intensity at P, because it will be the vector sum of the amplitude, displacement. Here will be the vector sum of two displacement. So intensity will also be more. Crust and crust. Now just imagine one thing. Does it matter that we are getting 8th crust or 14th crust? If we get 8th, 9th, 8th, 10th, 8th, 11th, 10th, 13th, any. Actually, whenever we are getting 2 crusts, we will have a maximum intensity here. Intensity is increased. That's it. So it doesn't matter whether the order of the crust is not important. But there is a difference. If I take a part of this wave, this crust and this crust, what is the difference in them in terms of this distance? This is actually lambda. So if I say I am getting first crust due to the first wave and first crust due to the second wave, this difference in their path covered is 0. So it can be only here when the two waves are covering the same distance. If I take this point here, one wave will come here, one wave will come, both will cover same distance. So the order of crust will remain same. It will be 5th, 10th, 10th, whatever. So del x is 0. If I am getting first crust due to first and second crust due to second wave, then what is this del x? It becomes lambda. Even now the intensity is more. Same way, if I get first crust and third crust, now del x is 2 lambda. So it means I can say that the intensity at P will be large if the path difference is 0, lambda, 2 lambda, 3 lambda, because the order is not important here. We should get crust. So, or I can write it simply n lambda, where n is 0, 1, 2, del x is n lambda. So whenever the path difference between the two waves reaching at a point is a multiple of lambda, then we get maximum intensity. We have worked in terms of path difference. I can take in terms of phase difference too. What is the phase difference between these 2 points? Lambda corresponds to how much of phase difference? Phase difference means one full cycle forward, or this is one cycle backward. Del phi, it is actually 2 pi for one full cycle. It is one full cycle ahead, 2 pi ahead. If there are 2 lambda, then it will be 4 pi. So I can find a relation between path difference and phase difference. 2 pi phase difference means path difference of lambda, right? 2 pi phase difference means a path difference of lambda. So what is the relation if I take del x path difference and del phi as phase difference between any 2 points? So it will be phase difference is 2 pi by lambda into path difference. I've just applied unitary method. If 2 pi phase difference means path difference of lambda, then unit or one phase difference means lambda by 2 pi. So del phi means path difference of lambda by 2 pi into this. 2 pi means lambda, one phase difference means lambda by 2 pi. So del phi phase difference means a path difference of lambda by 2 pi. Or phase difference is 2 pi by lambda 2 pi del x upon lambda. So this is how we can relate path difference and phase difference, and otherwise you can see 1 crest 2 pi and lambda. Okay, so what does it mean? Del phi 2 pi by lambda into del x and lambda 2n pi, where n is 0, 1, 2, 3, 4. So I can simply say for maximum intensity at P, the part difference is n lambda, phase difference is 2n pi, where n is 0, 1, 2. Right? Keep in mind, we have taken two conditions. Lambda is same, frequency is same, and the phase difference between them is not changing. That I will tell you what does it mean. Now, for the time being, let me take what happens if there is a crust and trough at this point. Again, the intensity will be 0. Intensity is 0 if I have taken the same amplitude. Okay, provided the amplitudes are same. So if the two amplitudes are same, intensity will be 0. And now tell me, what is the path difference or phase difference? One crest and one trough. It is lambda by 2. Or the next one, 3 lambda by 2 or 5 lambda by 2. So whenever the path difference between the two will be a multiple of lambda by 2, 3 lambda by 2 or 5 lambda by 2, then crust due to one will be on the trough due to other. So the intensity will become 0, or it will be minimum if the amplitudes of the two waves are not same. So I can say that path difference is odd multiple of lambda by 2. How should I write odd number? 2n minus 1 or 2n plus 1, where n is 1, 2, 3, 4. Now keep in mind, if we are writing 2n plus 1, then we should start n from 0. If we are writing 2n minus 1, n should start from 1. Okay. So this will give me the minimum. And same way, again applying phase difference is 2 pi by lambda into path difference 2n minus 1 lambda by 2. So lambda 2, 2n minus 1 pi. For minimum intensity, path difference 2n minus 1 lambda by 2 and phase difference is 2n minus 1 pi, where n is 1, 2, 3, 4. Okay. One better or more convenient way of writing it is lambda by 2 even multiple. It doesn't make any difference actually. Lambda by 2 even multiple, maximum. Lambda by 2 odd multiple, minimum. Pi even multiple, maxima. Pi odd multiple, minima. So it means if we have this situation, we have two waves of same amplitude, same frequency, and the phase difference between them is not changing, then the intensity in this medium will not be same at all points. This is what we call as interference of light. So interferences, you can note down if you want, listen very carefully. Non-uniform distribution of light intensity due to superposition of waves is called interference of light. Non-uniform distribution of intensity due to superposition of two waves is called interference of light. At points where the intensity is increased, the interference is said to be constructive. And the points where the intensity is reduced, the interference is said to be destructive. Now see what we have done in this case. A very important point is, now imagine at point P, we have two waves in such a way that one wave is this and the other wave is this. Will it be possible to get maximas and minimas? Actually not, right? Because in one part or half of the wave, so many parts of this are included. So actually we will not have a very well defined maxima or minima. It will change randomly. So we will not get this, right? So wavelength, the frequency needs to be same. Further, another point. If at P, due to first wave only, I am getting crust at one point, and at some another point of time, say after 1 second or fraction of that, I am getting trough, then again crust, then again trough, and same way this keeps on changing. Sometimes we are getting crust, sometimes we are getting. Will we get this well-defined maximum intensity at this point? No. At one moment there is maxima, another moment there is minima, and then again there is maxima. We will see just the average intensity, which is just the sum of the two. But here we are not getting sum of the two. It is increased at one point and at some point it has become zero. So to get this sustained maximas and minimas, wavelength, frequency needs to be same, and the phase difference. This is what we call, if you are getting crust due to one, crust due to other, it should remain this only with time. With time this situation shouldn't change. It should not be crust at some point, then at some another point of time, crust and trough, and then trough and trough, and then trough and crust. We will not get it. It will keep on changing and we will see just the average. So wavelength should be same, frequency should be same, and the phase difference between the two should not change with time. Such waves are called coherent waves, and these sources of light, they are called coherent sources of light. So we need two coherent sources of light to get interference. We are in the medium, at some points we will have maximum, at some points we will have minimum. We need two coherent sources. And two ordinary sources of light, two electric bulbs in a room or two candles, they are never coherent sources of light. Firstly, the light is not monochromatic, it's not single wavelength, and for two different sources, no, not possible, right? So wavelength is different. Even if we have the same wavelength somehow, suppose we take a sodium lamp and then divide its life into two, what we need to do is, how do we get light from any light source? The basic principle is, electrons are excited in the atoms, they move to the higher state, then they are coming to the ground state, and in this process they emit radiation, which if lies in this range from about 4000 to 8000 angstrom, then this is light. Now in one atom, electrons are moving up, coming down. In the source of light we have millions of atoms, and then no two atoms actually are behaving exactly in the same way. Means They are not excited or de-excited, they're coming to the ground state or going to the excited state simultaneously. So the light emitted by even two different atoms of the same source, that is not in phase. So that's why independent source of light, two independent sources of light, it's not possible to get coherent light. So we need some special type of sources to get interference. There are two ways we can divide either the wavefront. Take single source, monochromatic source. Monochromatic, one source of light. So we have, and then divide its light into two parts. Either by dividing the wavefront, we can take one source of light and then waves S1, S2. Here it is the division of wavefront. Or sometimes we can do even the division of amplitude. The light is, if there is some glass slab, light is coming in this way, it's moving and then it's going here, it's coming here, in this way. So next we will take an experiment which was performed by Young to prove the wave nature of light. We will discuss Young's double slit experiment, and then whatever we have done so far logically, that for maxima the path difference should be n lambda, for minima it should be odd multiple of lambda by 2, we will derive it mathematically by taking two wave equations. That I will cover in next class.